My name is Xinjin Zhang. I'm the coordinator of the project. We have been achieved a lot during the journey. The PED-ACT is a project that highlights the process innovation for developing PED. So basically, we have four tasks in the project. First is to use digital models or digital twins to create digital twins for 5 cases. The second task is try to use AI to characterize PED. And thirdly is try to create a matrix, which is a set of KPIs to access the PED for cooperation process. The last task is try to develop an innovative replication strategy to replicate upscale PED. So what we have achieved, of course, we have completed nearly all the 4 tasks so far. We still have a few months to go until the end of the project. So what do we have? We have created 5 digital twins models for all the 5 cases in Turkey, Austria, and also Sweden. And then we applied these all 5 digital models into the process of the planning and the design of PED. So they're part of it. So as the PED leader, 3 leaders said, so those models will help the decision makers to see different scenarios, what the sequence, what will be the result, what will be the investment. And for the AI calculation, we are the first project to apply the large language models into the calculation of PED. So basically, we use a lot of data sets from the common database, PED database, and then we abstract the main characteristics and also features, and then we created, based on that, we created the matrix to evaluate the PED, which will be useful for the cooperation process. Like we compare 5 cases crossly into different countries, and then we use the matrix consist of 8 sets of KPIs, and to see how each pilot performs under this framework. And then lastly, of course, based on the 3 previous tasks, we create our innovative PED replication process, and to see how to involve digital models, AI technology, and also cooperation metrics into the whole process to replicate PED into even larger scale. So that's what we have achieved in the project. Of course, from the beginning of the project, we had a lot of challenge. For instance, like we lack of data. What we collect the data usually is delayed, so which also delayed our development of digital models. And secondly, of course, the context in the municipality changes. So we have to, keep regular contact with new departments in the municipality. And lastly, of course, we have to keep our, heart when we start to have a passion for PED. And it's a long journey. Like each project will last 2 or 3 years. And during this journey, things can change and a new challenge can appear. So as long as we have the passion from the beginning, so we will overcome everything encountered in the project.
My name is İpek Gürseldino, and as METO we are leading work package 3 that is involved in developing digital PED references for all 5 pilot cities. The work package was about developing energy models that aim to understand what the energy needs, energy demands are from the pilots, and what are the possible solutions that can transform these pilots into positive energy districts. So in this work package, the first step was to collect data about pilots, to establish a baseline condition, a baseline model that is sort of an exact replica of the existing conditions of these buildings. And based on these, we develop models, energy models, that we can simulate for different climatic conditions, and with different time resolutions, we can calculate the energy demand, and this allows us the amount of energy that these districts are going to are in need at the moment. And based on these baseline models, we modify these models to develop alternative scenarios, PED scenarios, that can gradually transform the existing condition into a positive energy state. And this allowed us to, for each pilot, this allowed us to consider a number of scenarios and what their impact is going to be in terms of various performance metrics, from energy use, carbon dioxide emissions, costs, etc. I can generalize for all 5 pilots, I think. These 5 pilots were located in different cities that belong to different climatic conditions. They were all residential, but the density and the morphology of all of these pilots were different. So we had to take into account these differences in the modeling and also the scenarios that we are going to develop. For example, the Sweden case is a very cold climate that is heating dominant, whereas the Izmir pilot case is a very warm climate that almost has no heating loads but requires very heavy cooling. So the different energy efficiency scenarios and the renewable energy scenarios had to be informed by what is needed and what is also made available by the context. The Ankara pilot was nearby our university. It was a low-density, low-rise neighborhood, a very nice neighborhood that was in the middle of the forest. And the specific case here was that the energy use intensity was unusually low as compared to the rest of the city. And because of the high roof area as compared to the floor area, there was much potential for solar energy generation, which could very successfully meet the energy demand of these buildings. And we also evaluated the effectiveness of heat pumps for both heating and cooling, and we tried to understand on a monthly basis whether this technology could be used to decarbonize heating and cooling. We also could evaluate the changing energy demand with the changing climatic conditions with global warming, so we could make projections up to 2050 and try to understand how this building is going to perform in terms of building footprint, in terms of electricity demand, as well as costs in a very effective way. And this is supposed to inform decision making from a multi-perspective viewpoint from all stakeholders.
My name is Girish Nair, and I am a researcher at the Department of Applied Physics and Electronics at Izmir University. And I work here in this project doing some simulations related to a neighborhood in Izmir. Achievement we made was that we were able to do a simulation of a district, of a neighborhood, which showed us that it is possible to get a good simulation model with calibration, and we don't have to go for a very high resolution measurement data for calibration. We can have a low resolution data, but still it is possible to give a reasonable fit with the measured data. And also we also saw that in our neighborhood in Izmir, with that specific type of category of buildings, it was possible to get a good simulation result that is fitting the actual measured value with not so detailed building data. So that was a bit positive, which we think that could be applicable for other cases. The challenge, of course, is the availability of measured data to do it. It is a bit exhaustive, and also many times it's not that easy to get this data because of the legal requirement issues and so on. So that is one major challenge that we've encountered. We simulated 21 buildings in a residential area near to our university campus. Basically, the students are living in those apartments, and this was very useful because it showed the results. Simulation result has showed what is possible energy reduction through specific interventions that is we have simulated in that area, and this could possibly give pointers for the decision makers on what measures to prioritize in their quest to become climate neutral.
Mm-hmm.
One important aspect could be the climate, and the reason why I said climate because Umeå is at 64-degree north latitude, and in positive energy district discussion, most of the time you'll hear solar photovoltaic as one of the major technical intervention that could contribute for achieving positive energy districts. But it may not be the case in high latitude region. So we have to include the discussions about district heating systems as well. And along with that, another topic I would like to highlight is the mobility aspect. Because in Sweden, the electricity is relatively less carbon intensive compared to many other countries, and accordingly, it is important to have this mobility aspect that should be taken into consideration when we discuss and design positive energy district. And again, based on our study experience, it is more easy to have positive energy district in a newly developed area rather than to incorporating it in an existing district. So that would have create more challenges. And so once you have experience to have the PED in a newly developed area or newly going to develop area, then you can adopt those experiences in an existing district.
I'm reading about package 6, which is about co-creation. I think the biggest challenge was that we are coming from 3 different countries which have climate-wise already different conditions, but also the cultural context is very different. And so it was difficult, especially in terms of co-creation, to come to the same terms, let's say. And I think even though we speak different language, literally different languages, we managed to understand each other better, or at least have the perspective that the others have different basis. That's the reason why they are acting or reacting like that. We have been working as Wonderland in all 5 municipalities with all stakeholders, and this was very enriching as there are 3 different contexts. And so in a way, to be able to test our methodology, which is very much coming from cultural background or creative background, to test this with different stakeholders, municipalities, but also technical partners like energy suppliers, was very enriching. And it served also the purpose that it opened a little bit the constraints and the focus on only technical problems, but I believe we created a little bit empathy for each other, and also a little bit understanding that the citizens, the communities are actually interested in good solutions, but that we are kind of like in the energy sector at least, very far away from including them in the co-creation. And I think this is the main learning from all the 3 years. In a way, we try to work very bottom-up and artistic, so we use interviews, We used a manifesto to bring everyone's perspective together. We are employing exhibitions, which is growing and where people can add new opinions on it. We are doing a lot of publications, academic but also non-academic. We are writing a handbook for participation. So all those tools come together and they are kind of like getting the citizens but also the decision makers at a point as a supportive system. To, if they want to go the participation and co-creation way, then they have enough tools at their hands with workshops and so on to utilize that to make the voice of the citizens heard and integrated in their solution development. I think this is what we achieved so far.
My name is Muhittin Sırar. I'm working for Demir, and as Demir, we are leading work package number 4. Well, a common PET database is the first online and interoperable platform, and it compiles data on PET case studies and projects. It functions as a certain central hub, to share strategies and concepts for both new PET projects and also the renovation of existing areas. So the common database offers access to best practices and key performance indicators and helps guiding for future efforts in climate neutral urban development in our demo sites as well in Turkey. Well, PET database will be under JPI Urban Europe ownership, and JPI Urban Europe is promoting small, medium, and large cities in Europe for development of positive energy districts. The lessons learned from challenges, barriers of the case cities that are in the PET database will also guide PED-ACT case cities to develop new positive energy districts.
Hello, my name is Gazel Etminan and I am the work package leader of replication in PED-ACT and I'm project manager from AIT side, and overall I am thematic coordinator of sustainability to the communities in AIT. I think we learned a lot of things regarding positive energy district, and what we have achieved that we were able to kind of bring different replication model in the positive energy district in the different country, which was Austria, Sweden and Turkey. It was challenging because it is broad topic. It's not easy to give one prescription to every city, so it was a challenging process, and we are still on the development and finalizing that. So, but everything is going smoothly and good. Thanks. Actually, in the different country, it was different. Yeah. For example, in the case of Austria, we were inviting the energy communities of local energy communities with a different stakeholder, which was mainly citizen and owner of the building, to participate of the workshop and support us to this process. In the case of in Sweden was different because there was energy company were involved with the private owner, so the workshop and looking through this living lab was different. And currently we are in Izmir, so if you see that we are doing with the research institution and also municipality together to shape the roadmap that it is necessary for positive energy district. Yeah, in Austria, we have just one city as a climate city contract, which is Klagenfurt, which was not part of our case study, but among our project, we tried to apply this climate city contract, and what we found is actually it is really important from beginning of the process. We involve different stakeholders and looking through the investment of the plan of that, because a lot of regulation and a lot of changes needed a good financing instrument. So bringing different stakeholders, having awareness of the where the funding should come, where the money should come from. It is helping to the process. And also having the master plan from early stage for integration of the building, it is useful, and having the urban digital platform who support the process of monitoring and looking through the data that every city is collecting is necessary.
My name is Merve Marmartaş. I'm working with Demir Enerji, and as Demir Enerji, we are leading the work package 2 with the ESF. The PED-ACT project introduced the PED-AU-NET's common PED database to the PED community. Since it's a learning platform, the projects in the PED community could look for the legal, political, economical, social, and environmental barriers and challenges, also the drivers in PED cases. Besides the technological and non-technological solutions to overcome these barriers, also guided to the PED community to provide solutions to their PED cases that are being planned and designed in their projects. Most of the projects in the PED community aim at planning and designing PEDs, like PED-ACT. In some of the projects, digital twins of the districts are being developed. Learning from other cases on developing digital twins helped a lot. Besides, the PED landscape that was developed with joint efforts of the community helped PED-ACT to understand the different definitions of the PEDs and barriers, helped PED-ACT for contributing to the development of the PED matrix. Besides, the deep dive series helped a lot, that we learned from other PED sister projects on what are they doing from different subjects like flexibility, climate impact assessment, and how to introduce the PED and how to design and replicate the PEDs in other sites.